Good afternoon and welcome to lecture number 4. And it's a great day again today in our little course. Does that sound okay? Good. Because today, for the first time, we're going to do really statistics, real inferential statistics. Let's see. We have a nice plan like this. We are going to split it in two, like this. And you're going to hear about the mean a lot. And then we're going to hear about the standard deviation also. And then you're going to hear some great stories about laws of nature during those 2 by 45 minutes. So let's begin. Basically, this is what you're going to learn today. Here's everything from a methodological point of view. What if we have this little example that we've seen previously, that we sampled 10 persons and measured their heights? Then we've already seen in lecture number 1, we told you how to compute the sample mean and the sample standard deviation as a summary of what those data are telling us. It tells us that the mean of the height was 178 centimeters. The standard deviation of the height was 12 centimeters. What does that mean? Standard deviation of height is 12 centimeters. Think about that. Think about variability. It means that people on average deviate from the mean with around 12 centimeters, right? It means that most people, 95%-ish, would deviate within plus minus 2 standard deviations, right? If the mean is 12 centimeters, then half of them will be between 0 and 12 centimeters away, and the other half will be from 12 to 24 centimeters away, sort of roughly speaking, right? So it tells a story about this. Already tells a story about the distribution of heights, that it's 178 in the center. It's 24 from that is 154, up to 24 plus, that is 202 with my ugly numbers here, right? This is the story about the height population that these numbers tell us. To be more specific, to use it really formal, inferential, we say that the 178 centimeters is the sample estimate of the unknown true mean height called mu. And the sample standard deviation is the estimate of the unknown but true variability of height in the population sigma. So it's the estimates of the population values. I think most of us would think like that, maybe without realizing. But now in this course we are formal about, we have the sample, we have the data. Sometimes we use the data to infer something about the population, to say something about the world. We already did this. Today you're going to learn 2 methods, basically. And a lot of discussion of why they look as they do and the understanding of it and how to compute them in R, which is easy. Here is one thing, what we're going to spend most of the time on this one. Means are really important. There are most things that we compute in the world are means of one kind or the other. Actually, the variance itself is a mean of some kind, but that's maybe not so important. Now, the formula goes like this. You take the observed average, you take plus minus roughly 2.26 in this case. We'll get back to where that comes from, of course. And then we take the standard deviation divided by root n. That's a formula for an interval, right? The mean plus minus 2 standard errors, actually, is this confidence interval we see here. So we believe, now we're going to be loose, we believe that the true mean height based on this little sample of 10 persons would be somewhere between 169 and 187. It's pretty unsure, right? But with 10 persons, it's pretty difficult to be very certain about what is the true mean height really. And we are going to learn a similar, we don't see the formula now, but it'll come in the lecture, of course. We're going to learn similarly how to, and that's maybe conceptually challenging for someone now. We're also going to realize that when we compute a standard deviation, it's not the truth, of course. That could also be different from time to time. A standard deviation itself comes with a variability. There is a variance on the variance here. Whoa. But I'm sorry, that's how it is. So we could compute also, similarly, a so-called confidence interval, abbreviated CI, confidence interval. That's the topic of today. We'll see how. That's basically the topic of today. You're going to learn some method boxes, how to do this. And I'm going to teach you what it means. Questions? Any doubts about why you are here now? By the way, it's the statistics class you came to, right? Statistics is about learning from data. That's why we are here. Learning from data is going to be 6 out of 8 hours part of your engineering life when you leave this university. Maybe 7 out of 8. Maybe 7.5 out of 8 hours a day. You'll be learning from data as an engineer. I'm sorry, but that's modern life. So, I prepared as usual. From my perspective, it works pretty okay with this Kahooting. If you think it doesn't work okay from your perspective, I mean, my email is open. I didn't get any hate emails yet, and anyway, let's see. Thank you. I need you to play, otherwise there is no game if you don't play. I'll simply try to avoid looking at the name list. I'm not at all worried about the future of the Danish society when I'm looking at this list. You are going to carry on this society in the future, right? You guys. What's going on with you? I don't know. I hope you English-speaking persons, you don't understand everything on this. Anyway. Well, now it gets serious. Yeah, that's okay. The yellow one was a bit of a trick question. Nevertheless, it's not correct. Interesting name, but you're on the top.